What's up, Joel? So today you're going to be learning about symmetry, and there's a couple different vocab words I will be teaching you. If you have any questions, let me know. So our objective today is to identify and describe symmetry in geometric figures. And so there's four vocab words. There's symmetry, line of symmetry, and rotational symmetry. And so diatoms are microscopic algae that are found in aquatic environments, and scientists actually use a system that we developed in the 1970s to classify diatoms based off their symmetry. So in reality, a lot of algae and animals in the ocean and waters have a lot of symmetry, and so that's kind of where we came up with the idea in geometry and math of symmetry. And so official definition of symmetry is a figure has symmetry if there is a transformation of the figure such that the image coincides with the pre-image. So it has to land directly on top of the pre-image to consider it as symmetry. And so line symmetry, a figure has line symmetry or reflected symmetry if it can be reflected across a line so that the image coincides with the pre-image. Now the line of symmetry, also called the axis of symmetry, divides the figure into two congruent halves. So for instance, this heart does have line symmetry and it has one line of symmetry. So let's look at this image here. We're going to say if it is a line symmetry and how many lines of symmetry it has. And so, yes, it is line symmetry, and we can actually cut this in several different ways. We could cut it in half, it would be the same. We could cut it down this way, and it would be the same. So let me kind of get my marker out here. We could go, I thought I got it out. I didn't. But anyways, we could cut it in half, and then we could go around 8 times to get 8 lines of symmetry. This one does not have a line of symmetry, right? We can't cut this any way to have it connect and pre-image across a line of symmetry, so there's no line of symmetry here. This one does, in fact, have a line of symmetry. We could cut it half, we could cut it across, and then we could also go twice diagonal, so 4 lines of symmetry. A, yes, we do have 2 lines of symmetry for that one. It would look like that. B, it does, in fact, have line symmetry, and we could cut it once right across there. C is line of symmetry, and again, we could cut it once with a line of symmetry. Rotational symmetry is a little bit different. A figure has rotational symmetry or radial symmetry if it can be rotated about a point by an angle greater than 0 degrees and less than 360. So if it can't be rotated and then right on top of its pre-image without going a full 360 degrees, so then it has rotational symmetry. So let's kind of look at an example here. I'm going to pass this part. So we can look at the square here, and we can actually rotate that square 90 degrees 4 times before it goes 360 degrees to make it have 4 rotational symmetries with a degree of 90 degrees. So let's look at some examples here. A does not actually have rotational symmetry. We can't rotate that to land on top of its pre-image at all until you go a full 360 degrees. B does, in fact, have rotational symmetry. We could rotate that image 180 degrees, so we would have 2 rotational symmetries. C is a little bit different of a story. It's kind of like that square. We could rotate this image 90 degrees 4 times, so we would have something like this. A also has rotational symmetry. We could rotate that 120 degrees for 3 times. B does, in fact, have rotational symmetry. We could rotate that 180 degrees for an order of 2. And C does not have rotational symmetry. We can't rotate that until it goes 360 degrees, so no rotational symmetry. So let's kind of go through these. Let's do a few examples. We're going to tell if it has lines of symmetry, if it's rotational symmetry, and so on and so forth. So yes, this does, in fact, have, it does not have a line of symmetry, but it does have rotational symmetry. We could rotate this image 180 degrees for an order of 2. This image does, in fact, it does have lines of symmetry. We could cut it 1, 2, 3, 4. 1, 2, 3, 4 times, and then we could also rotate that image 90 degrees 4 times as well to get something like this. 1, 2, 3, 4. A, we could rotate quite a few times and also have some lines of symmetry. We could rotate it 5 times to land it exactly on top of each other. That's kind of a hard image to see, so I apologize. B, we could also have some lines of symmetry. We could have 1, 2, 3, 4, 5. It looks like 6, 7. Yes, right.